वेलकम माय डियर फ्रेंड। जैसे कि हमने लास्ट वीडियो में जो कुछ न्यूमेरिकल्स देखे, उस मैक्सिमम न्यूमेरिकल्स में हमने रेजिस्टेंस के ही न्यूमेरिकल्स देखे हैं। तो अभी ये सेकंड वीडियोस में हम जो यूनिट नंबर 1 में टेम्परेचर बेसिस और टेम्परेचर कोएफिशिएंट के बेसिस पे जो न्यूमेरिकल पूछे जाते हैं उस न्यूमेरिकल को सॉल्व करने के कैसे करना, कैसे न्यूमेरिकल्स आते हैं और कैसे उसको सॉल्व करना, ये सारी चीजें हम यहाँ पे देखेंगे। तो लेट मी फर्स्ट न्यूमेरिकल इन फ्रंट ऑफ यू। फाइंड द टेम्परेचर कोएफिशिएंट ऑफ द रेजिस्टेंस ऑफ अ मटेरियल at 0 degree Celsius, which is used in a resistor. If the resistance at 25 degrees Celsius is 50 ohm and at 70 degrees Celsius is of 57.2 ohm. It means we have to find here temperature coefficient. But for the numerical, first we write the given data. The data will be given is that at temperature 25, the resistance is 50 ohm. At temperature 70, the resistance is 57.2. We have to find the resistance at 0 degrees Celsius. That is the temperature coefficient. So for that purpose, at 25 degrees Celsius, we just write here formula at R at resistance at 25 degrees Celsius will be equal to R0 into 1 plus alpha 0 plus T25 at R0 plus alpha 0 into 25 because temperature is of 25 degrees Celsius. Okay. Now after that, at 70 degrees Celsius, that R70 is equal to R0 plus 1 plus alpha 0 into T70. यहाँ पे भी temperature at is 70 degree. We just put that values here. Now by dividing equation 1 and 2, ये दोनों equation अपने को मिल गए। ये दोनों equation को अगर आप divide करते हो तो we get ना R25 upon R70 is equal to R0 upon 1 plus alpha 0. अब इसमें क्या क्या चीजें कैंसिल होगी? तो R0 get cancel. Resistance at 25 is 50 ohm. Resistance at 70 is 57.5. 1 plus alpha 0, 1 plus 17 alpha 0. So as per that, we just get some equations in terms of alpha 0. Now after solving that equation of alpha 0, we get a value of alpha 0 is equal to 0.003636 per degree centigrade. Okay. Now by taking this value of alpha 0 in certain equation number 1. So if you put this value of alpha 0 in equation number 1, automatically we get a value of R0. What's the way to find out? जो अपने को 0 R resistance and 0 के लिए निकालनी थी वो वैल्यू अपने को यहाँ पे मिल गई. So in that way we can use the temperature coefficient formula and we can find any numerical. Here the important the thing is that important formula is that this R. ये formula important है. By examining or by putting the proper value, you get a proper answer. Okay. So this is the first numerical. I hope you understand it. Then we move for next. The resistance of the transmission line is 126 ohm at 20 degrees Celsius. Determine the resistance of a line at 35 degrees Celsius. The temperature coefficient of the material of a transmission line is 0.0426 ohm at 0 degrees. Now first of all, we go to the given data. The data is given is that resistance at 20 degrees Celsius is 120 ohm. The resistance and temperature is of 20 degrees Celsius. Alpha 0 will be given. We have to find out our temperature at resistance at 35 degrees Celsius. So first of all, what we do at 20 degrees Celsius, R20 is equal to R0 plus 1 plus alpha 0 T0. Now here we does not know the value of R0. So first of all, we find the value of R0 here by putting all this value on the other value. And after getting value of R0, we just put a formula for R35. That R35 is equal to R0 plus 1 plus alpha 0 T35. Now T35 पता है 35 डिग्री सेल्सियस. अल्फा 0 तो ऑलरेडी गिवन था, वो भी पुट कर दिया. R0 पहले निकाला था, अभी वो वहाँ पे पुट कर दिया. So here we got the resistance for R35. That resistance available for 35 degree Celsius will be equals to 127.05. In that way we can solve this types of numerical. कि एक रेजिस्टेंस का पूरा डिटेल दिया है, फिर भी उसका अल्फा 0 पहले निकालो, उसका R0 पहले निकालो, then after getting the value of R0, put this value in terms of another equation and you get that particular resistance. This way we can solve this types of numericals. Here another numerical will be in front of you. The filament of 60 watt and 230 volt lamps has an normal working temperature of 2000 degrees Celsius. and find the current flowing through the filament at the instant of switching. The lamp is cold. Assume that the temperature of a cold lamp is to be 15 degrees Celsius at alpha 15 log 0.05 Celsius. As for that, the given data is power is given of 60 watt, voltage is 230 volt, alpha 1 is given of 0.005 degrees Celsius. T2 is temperature given here that nearly equals to 2000 degrees Celsius, and T1 is of 27 degrees Celsius is given. As for that, you just first find the value of current, that I is equals to P by V, because we know the formula for P equals to I into V. So I is equals to P by V. Just find value of I. As for that, I just find a value of resistance R. R is equals to V by I. Now after getting the value of R2, uh, indirectly R1 is known for us. So from that we just find value of the current I also. In this we can solve this type of numerical very easily. These numericals are very much simple. By just putting the formula and inserting the values, you get the clear cut answer for that. Okay, so we can solve this type of numerical very easily. Another numerical will be from you. The two conductors, one of a copper wire and another is of aluminum, are connected in parallel. At temperature 25 degrees Celsius, both the conductors carry the some current, and calculate the amount of current passing through each conductor at temperature of 36 degrees. Here, the copper and aluminum conductor are carry the equal current of 20 degrees Celsius. There, the resistance are to be same at this temperature. Assume that the temperature coefficient of resistance is 0 degrees Celsius or 0.0043 degrees Celsius and 0.0038 degrees Celsius for copper and aluminum. Let the resistance be R ohms at 20 degrees Celsius. If R1 and R2 are the resistance of copper and iron conductor respectively at 60 degrees, then R1. First we put the value of R1. R1 is equals to R is equals to we find the value of R1. We find the value of R2. If I is the total amount of current at 100 degrees Celsius, then the current in a copper conductor will be given as I into this R1 and R2 are in parallel. Therefore, R2 upon R1 plus R2. This is done by using the current division rule. This formula will be used for the current division rule. We put this value by using the current division rule. Now, after putting this value by using current division rule, we can easily insert it. Then the current in the aluminum conductor will be given again by the current division rule, that I is equals to R1 upon R1 plus R2. We get this amount of current. Therefore, at 60 degree, the copper conductor will carry the 49.57% of total amount of current, and total remaining 50.43 will be carried out by the aluminum wire. It means we have to sacrifice the amount of current through aluminum as well as through the copper conductor. Okay, so this is a simple numerical. Another numerical will be from you. 100 watt 100 watt 250 volt bulb is put in a series with a 40 watt 250 volt bulb across a 50 volt supply. What will be the current drawn, or what will be the power consumed by the bulb? Will such a combination work? Here the resistance for that 100 watt is we have to find out, that is 625 by using formula V square by P. Then resistance of 40 watt 250 volt bulb will be R40 at 25 250 upon 4 P 250 square upon 40. Now, when both the bulbs are connected in series across 500 volt supply, the current through each will be 625 plus 150 1532.5 will be equal to 2157.5. Then circuit current is given by I is equals to V by R. So we just put the value and we try to find out the currents. After finding the current, अपने को बोला कि पावर कितना कंज्यूम हुआ है उसको निकालो. So further we will use formula for P is equal to I square R. So here I put the value of current I, and as well as the resistance for 100 is 625. Just put the value and get the power for 100 watt as well as for 40 watt. Now after getting the value of power, we have also find out, we have to also find out the voltage across the bulb for 100 watt and for the voltage across the 40 watt. For that purpose, we use the formula V is equals to I into R. Okay. So these are the simple numericals that will be asked in paper sometimes. I hope you understand all the numericals. In case any doubt, in case any problem, in case any issue, you can ask. Thank you. Keep watching next video.